All right. Good call. Dun, dun. All right, let's take a look at what we got this week. Please, if something came up yesterday and you did not finish that test and you wanted to, let me know. Remember, you don't have to. You only have to do 2 out of 4. Like if we have 4 of them, you have to only do 2 of them. I take those 2 grades. You can do all 4, and I'll take your best 2 grades, but just keep that in mind. So if you do need this reopened for you or whatnot, I had somebody who said that it didn't give them the right time. So I had to give them extra time, which was no problem. The equilibrium packet, we will begin that today. If you are printing this, please only print 6 pages. This is living right now. This is a living document. I'm making changes. I've got the first 6 pages, I think, where I want them. But the rest of it may change. So if you print it out, then you're going to be sitting there looking like, this doesn't look like I have it. So just keep that in mind. How the formula works in Q. To tell you the truth, I'm really dividing this out for you guys. Thursday, I don't think it affects you guys as much, but that is that early release day. Keep that in mind. Your later classes may be different. That means that for IB, you'll be just working on your individual assessment for that. So keep that in mind. And then rice tables, I think last year we called them ice tables if you were in with me for X chemistry. But that is the thing about this part. This is where, and you might be finding this out with all your classes, but this is where we actually, started to, for X chemistry at least last year, this is where we started to actually be in lockdown, the first lockdown. All right. Lockdown. Give me 1 second. I gotta grab my notes. I forgot them in this back room. I was looking at them while I was eating breakfast. Yeah. Hey, you're gonna love this. I had a German breakfast. Sausage and sauerkraut.
Ew.
Can you smell it?
No, but that's disgusting.
How is that disgusting?
Sauerkraut's gross.
This is fermented cabbage. Do you like kimchi?
No.
What is kimchi? It's the same thing as sauerkraut, except for it's usually spicy. It's a Vietnamese dish.
Makes sense.
Talked to Miss Anti-Gut Bacteria over here. That doesn't eat anything for a minute. Do you eat yogurt?
Yeah.
Okay. You're gonna be okay, bro.
Even though lactose is.
Oh, are you really? Don't like kimchi? Jeez. There's a place I haven't been there in a while, but it's like a Korean barbecue. Yeah, it's a Korean barbecue. Yeah.
Oh, on the east side.
Mama's.
Yeah.
Yeah. Have you been?
No, but
Yeah, like they've got like 12 different types of kimchi almost. It's like amazing.
Is that the one with the all you can eat?
I've never seen that.
Yeah.
They have the barbecue in the middle of the table though, like where you can.
Yeah.
It seems like all you can eat because they bring out so many little side dishes.
Yes, and yeah, that got my friend in a lot of trouble one time. Cause like they just like kept bringing him food.
Oh, and he was like.
And like yeah, and then they like rang it up and it was like $130, and there was 4 of them. They're all seniors. And like, they were like, oh.
Huh. That is definitely expensive lunch or dinner.
Yeah.
Whew. All right, equilibrium. All right, so if we take a look, this we've talked about it before because you guys have had chemistry before, but we know that we can take hydrogen plus oxygen and form H2O, right? Well, we can also take water and break it down with electricity and form hydrogen and oxygen. Now, this does take energy, so we know that one of these processes is more favorable. One also has a lot more disorder. And keep in mind that things that release energy and increase disorder are usually favored upon. So we know that this reaction is reversible. Well, some reactions are reversible. This one, it's not likely to happen unless you have an electricity source. For example, a lot of the water created on the earth and stuff like that, they attribute to lightning storms, things like this. Other reactions are going back and forth completely all the time. Equilibrium is basically the point at which the rate of the forward reaction is equal to the rate of the reverse reaction. There's still changes going on, but the system is at equilibrium. Now, the thing about equilibrium is you've got it everywhere. For example, if I just take, I think if you're in my class or whatever, I told you that my brother would make Kool-Aid, but he would use way too much sugar in it. So his idea was that if he heated it up, the sugar would dissolve, because you could dissolve more sugar in hot tea than you can cold tea. But whenever you cool it down, it reaches what we call the saturation point. So on the bottom of it, you would get this layer of sugar, right? Now that layer of sugar is constantly changing. Water molecules are going down and pulling off some of the sugar from the crystals, dissolving it. And then you also have a deposition where some of the sugar that's dissolved is going to crystallize on the surface of those crystals. Even though we're at equilibrium, there's no overall net change between the amount that's solid and the amount that's dissolved. It is constantly changing. So just keep that in mind. That's why we say it's dynamic. Instead of using a one-way arrow, we indicate it with a two-way arrow. A lot of times you'll see when it's written, it'll look like that more, but this is the one that the computer likes. You guys see that okay? That's pretty blurry, isn't it? See if I can fix it. Huh. I think we're just gonna have to get closer. Better? All right. So once equilibrium is established, again, the rate of the forward and rate of the reverse is equal. That keeps the concentration of the reactants constant and the concentration of products constant, but keep in mind, they're always changing. So what that means is the actual particles themselves that are products or reactants are not always the products or always the reactants. They go back and forth, but the actual concentrations don't change. Yeah? Are the concentrations equal to each other? Not necessarily.
Not necessarily.
Right? Not necessarily. So just keep that in mind. The nature and properties of the equilibrium are the same no matter what the direction that you approach the problem, nor what type of problem. And what this means is if we're talking about something dissolving, we have the solubility product equilibrium. If we're talking about reactions of gases or aqueous solutions, we have the concentration equilibrium. If we're talking about gases, we may have partial pressure equilibrium. If we're talking about acids, we have the acidic equilibrium. Bases, the basic equilibrium. You may remember them as Ka and Kb. Right? So we have all of these different things, but the way we solve or approach these is basically the same. One thing you need to know is you got to know how to find concentration, which is moles per liter. key thing there. The equilibrium constant, K, is temperature dependent because it deals with rates, right? Now, the cool thing is if we take just a general reaction, these are the coefficients. These are the reactants, A and B. These are the products, C and D. The equilibrium constant is products over reactants. And we take them to the power of the coefficient. Now, again, why is this? Well, when we do this, we look at these as elementary reactions, which means that their rate laws would be based on their coefficient. So we are comparing the elementary rate of the products to the elementary rate of reactants. Does that make sense? We have a forward and reverse reaction, right? So if we take a look, remember the elementary rate laws, we take the coefficient and we turn that into the superscript. We take it to the power of that. So we break that down and we put that on top and we compare that to the reactants, which we put on bottom. And remember what equilibrium states. The rates are equal. So this new K is our equilibrium constant. Products over reactants. Remember, we've done this, but that indicates molarity or concentration. Here's all the fun different Ks you can have. Concentration. This can also be for gases, but partial pressure is also like for gases. Gas concentration, you have the volume of the container, you know the moles that are in there, moles per liter. Still, acid equilibrium, base equilibrium, water equilibrium. Does anybody remember what Kw equals? 1 times 10 to the negative. Home? Yeah. I was wondering how long these later units, because of lockdown, we're going to take. 1 time, what's the pH scale based on? 0 to what? 14. So if we look at Kw equals 1 times 10 to the negative 14. If you remember that, yeah. Solubility product and formation of complex ion. Now, since it is a relationship between products and reactants, if the number is greater than 1, that means we have a larger number on top, which means at equilibrium, the products are favored. If the number is less than 1, that means we have more reactants at equilibrium, because remember, it's products over reactants. And if the number is equal to 1, then what? Yeah, right? We have relatively equal amounts, concentrations of products and reactants at equilibrium. Whenever we're talking about solids, pure solids, and pure liquids, we make them 1. So the concentration for these would be 1, or they're just ignored. Because 1 to any power is what? 1 multiplied by any number is that number, right? Dun, 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 dun. I think that this right here will make more sense if we go and actually make some of these first. Basically, I mean, if we have products over reactants and we solve for K, if we reverse that reaction, then we would have reactants over products if we looked at the reverse reaction. So then K would be the inverse of K. That may be hard if we don't actually have Ks. So let's go ahead and solve or show how to solve for some Ks. And is this the only thing I wanted to get done today? Is this short. Show formula setup. How formula works. Okay, cool. Yeah. Formula setup. This is quite easy. So if we take a look, we take the products and we put it over the reactants. So K equals the concentration of PCl3 times Cl2. The coefficient for each of these is 1 over PCl5. Easy enough? Let's try D. Somebody want to help me out? Who's going on top? A lot of times you might see this as K sub EQ if it's a basic equilibrium. HI is going on the top. What's special about it though? Second power. Now, this is the part, I mean, you guys realize that this is the first time I've ever taught this to the AP class. So if this seems very elementary to you, I don't want to sit here and stick on it for 10 minutes or whatever, but I want to make sure you guys have understanding. I'm sure that if you do get it, this is just too easy for us. And sometimes I feel like maybe it's not too easy for them and I jumped over something. Please, I know that some of you are good about that, telling me to slow down and stuff. So what's not going to be on the bottom here? Iodine. Because as we said, it is a solid. So it would just be replaced with what? 1. Right? Those are the things you have to check out. If you don't have one that fits in, then the K sub EQ then is just products over 1, right? So at the top there, we had a lot of the gas stuff. And again, we can go with concentration on this or the pressure. I think we actually saved the pressure stuff for a little bit later. Yeah, no biggie. Here is that solubility product constant. A lot of times if we have, it shouldn't be there. Something solid and we're dissolving it. So again, that would be very similar. We might call this solubility product constant, KSP equals Ag plus Cl minus over 1. And again, if you didn't write the over 1, that's not a big deal. You don't have to. But do keep in mind that some of these have that solids, liquid stuff, and some don't. So now let's put some math with it. Consider the reversible reaction. This is that H2 plus I2 yields HI. So we already have the K sub EQ equals concentration of HI squared over H2. They give us H2, they give us HI, 0.060 over 0.015. K does not have units. This K, the equilibrium constant, does not have units, unlike the rate law K. Yep, thank you. So if we take a look, 0.06 square divided by 0.015. Get 0.24, and that is K. What's favored here? Products or reactants? Reactants, right? K is less than 1, reactants favored. K greater than 1, products favored. All right, let's try another one. Let's try number 3. So if we take a look, case of BQ equals, we have a solid here, so that's going to be 1. So we're going to have, actually, I don't even need a line here because A3AL3 plus and OH negative cubed. We actually have OH. They give us aluminum hydroxide, but that doesn't matter, right? That's just sitting there on the bottom. Keep in mind that basically that means it's present, and things can only react if they're touching the surface of that, right? And that's why the concentration and stuff like that is not a big thing for that. For liquids, the same thing. Only where the surface of the liquid might be touching something else, or if it's something that's in the liquid, it can only affect on that if they're actually touching. We have to have those collisions. Whenever something is dissolved or in gaseous form, there's constant mixing and colliding, right? That's why the solids and liquids are left out or just put as of one. They're present. Everything else is based off of these concentrations. So now I'm going to plug this in. I want to actually solve for the concentration of aluminum at equilibrium. So I'm going to divide both sides by OH negative 3. It will cancel out on that side. So K sub BQ is 1.9 times 10 to the negative 33rd. Again, no units. We know the units for concentration are going to be moles per liter. So we just have to keep that in our head. We're going to take that 1.9 times 10 to the negative 33rd and divide it by 8.7 times 10 to the negative 9th cubed. Everybody remember how to put these fun things into our calculators? Use the E button, negative 33, divided by 8.7 times 10 to the negative 9th, but we need to cube that. Probably should put some parentheses around that. Cubed. Times 10 to the negative 9th. And we get 2.89 times 10 to the negative, actually 2.9, if we look at significant digits, times 10 to the negative 9th moles per liter. Let me ask you this. What is there more, in this case, products or reactants? 1.9 times 10 to the negative 33rd, less than 1. Yeah. Cool.
Mr. Jackson,
Yeah.
do the 3 grams just not matter in that equation?
You got it. It's there to basically see if you use it, you will be wrong. And the reason it doesn't matter is because this is a solid. So on the bottom here, instead of that 3 grams or figuring out any calculation or whatnot, we just note that aluminum hydroxide is present. So we just put it as 1 because it is a solid. Cool. Yes. All right then. I'll take that as a yes. So consider the following reaction, reversible reaction. PCl5 yields PCl3 plus Cl2. If we take a look, if we have the following concentrations, okay, this is the equilibrium constant. So there is something, if you are not at equilibrium, you don't use K, you use something called the quotient. So we're actually going to use Q there instead. The cool thing is it's set up just the same as K. The only reason we call it Q is because it's not necessarily at equilibrium. It could be. But basically, this is just some set point in time that we want to investigate. So we have products. We're getting all those books back out. Over reactants. It's a 1 to 1 to 1 to 1. So everything is 1. We're going to solve for Q. Now, to tell you the truth, this is what I love about this. I could type this directly into my calculator with no worries because I have everything written out here and I can pull those things from there. I'm doing this part for you. So I will rewrite it so that you can make sure that you can see where every number goes. But under normal circumstances, I would not rewrite this. I don't think you would have to for the AP test either. Products over reactants, 0.25 times 0.1 divided by 0.005. We get 5. That is Q. How does that compare to K? K is much greater than 5, we could say, right? So at this point in the reaction, we took a snapshot and we said, okay, this is where we are. What do you think is going to be happening with this reaction as it progresses? Is the forward reaction going, the forward reaction rate faster or the reverse reaction rate faster? Because they're not at equilibrium. This is the critical thinking part. We have a 5 product to 1 ratio. We need at equilibrium, we need a 150 to 1 ratio. So what does this system need to make more of? Products, right? This system needs to make more products to reach equilibrium. So the forward reaction will be faster and will make more product until that ratio is reached. That's basic equilibrium. I would set up a few of these. Again, I don't force you to do practice, but you know that practice will help you. Set up a few of these. I'll try to get the answers up for the end of the week. And then I would work through this page. And if you want to see any of these tomorrow, by all means, ask it and we'll do it. And then tomorrow we will do some continued problems. And we will take a look at, I don't know if we'll take a look at rice tables tomorrow. Maybe we'll take it easy for most of the week and then we'll look at that stuff. I don't feel like going through the quadratic equation. It's been quite some time. So we'll deal with that probably later in the week. Have a great day. We'll see you guys tomorrow. If you have questions, as always, stick around, ask away. Otherwise, do some practice problems. Oscar, I'll see you later. They're already all gone. Look at that. They get out fast. Huh? What's that mean? Is he one of the ones that stays in? Dylan, Dylan's usually one of the last ones.
You know, sometimes I love your teaching so much, so I stay for second and third year with you.
Yeah, right? My special soothing voice.
Sometimes I fall asleep.
I should probably stop the recording then. What are you doing? Sounds like to tell them with what Monday synchronous?
No, like how students are underrepresented when students are made, students are overworked, like, and especially like in this like in the pandemic, like teachers are overworked and don't have the resources to help us, and are just like told to do things that are absolutely ridiculous. And then like administration won't listen to anything we say ever. Like they never take us seriously. Counselors can't even make our schedules on time. Obviously, real personal issues. And the district, like everybody is like, we care about your mental health, we care about your mental health, and then when we actually need them, like, they don't, like, they Like they gave us a technical solution this time. They gave us like stress relief for like anxiety relief kits, and it was like a cotton ball and a paper clip.
That's awesome. I would have given you a bag of lard, like a little Ziploc bag of lard that you could squeeze on.
Better.
A cotton ball and a paper clip.
Paper clip.
That's not real, right?
No, it's real.
That sounds amazing.
No, it's
Like
real.
somebody was like, "Yeah, just throw a few of these in here. This is all we got left." Here, yeah. That's amazing.
Like it's just ridiculous. But like, and Washington Township does not care about their students; they care about their. Like that's not like that's just not.
Yeah, but you guys helped their image with all of the scholarship money and all that, right?
Yeah, but if
Yeah.
they would like, I just wish.
I think we all know that there's groups, students in this school that are decently represented, and there are groups that, and if you're feeling this,
I feel like as a whole,
that you know that the other
students
groups.
are very underrepresented in certain domains, and like they do not take this into account at all whenever they make a decision. They're like, well, this sounds good. Like let's just do that. Like a stupid homeroom thing. Like that's ridiculous. Like they make lesson plans for you guys, and like they don't even like I don't know.
Are any of you guys in my homeroom? No.
Like
Yeah. I just put the links on the homeroom page. If they want to come in, they can. I got some pretty cool. What's that? Sam's brother. What's the guy that makes all the music? Sam something. He graduated like Lardy. Yeah, Lardy. Laddie. I got his brother in my homeroom. He's pretty cool. I got some kid named Cole something. That's pretty cool. And I got some girl that like she wants to argue like you, but her vocabulary isn't good enough. So she tries to get into fights with me about like homeroom stuff, and I'm just like, sweetheart, like no, not today. Isn't she special?
Wait. You Cole Little?
Yeah, Cole Little.
I know.
Cole Little. I had his brother a few years back too.
Yeah.
Huh?
He egged my house.
Yeah. He egged your house?
He egged my house.
What did you do to him?
Went to his house at like 2 a.m. and woke his mama, said he had to clean my house or else.
No, what did you do to him that you required egging?
Oh, he bombed our Zoom in English class.
Are
And
you
I knew it was
serious?
him, and he used my name. So I told our teacher it was him because I was about to get in trouble.
Are you serious?
Yeah.
Like he typed Emma Gage as
No,
like,
it was Emma, and then he let the teacher let him in
oh
because he thought it was me.
yeah.
And then I had to like vouch for myself, and he was like, Emma.
Who is
And I
this
was like,
teacher, this English teacher?
Mr. Stillman?
That's amazing.
Yeah, and then
I've never been Zoom bombed.
Yeah, Cole
Yeah.
didn't even get in trouble for it, and then he egged my house. And
Yeah.
we're probably gonna press charges
Jeez.
because he can't keep his mouth shut.
Yeah. Dr. Kelty gets Zoom bombed all the time. I wonder if this Rick Scanlon, I wonder if he gets Zoom bombed all. What did he do? What did Cole do? I'm Zoom bombing, yo.
No, he had someone else do it, and then like the person like cussed him out.
Cussed out Mr. Scanlon?
Yes, it was ridiculous. And then
See, I had that with Jeremy Mormon last semester, but he wasn't Zoom bombing me. He was just one of my students.
Wait, Jeremy on the tennis team?
Yeah. He gave me Tide Pod, and he's like, "Here, Miss Jackson, I got you a Christmas gift. You want to use this thing?" And then he's like, "Get some snacks for you too," and he gave me Tide Pod. Yeah. Said, "Don't eat more than 2 at a time." Does anybody know what he's up to now?
Same old.
Well, no, I don't know if he's a student here anymore.
Yeah, he's a senior.
He is still here.
Yeah.
Because I looked at him because he's not in my chemistry class anymore. And last time he got out of every other like they put him into stuff like he was in my first period last time. So whenever I took over the AP, he went to another chemistry teacher and he's like, "Nope, this ain't gonna work," and like just logged out of the Zoom and then bombarded his counselor with until he got put back into my class, and maybe he found somebody that's gonna work with him. But whew,
What a kid.
I had him and Krishan in the same
Oh
class,
my gosh.
which was amazing.
That sounds like a hot mess.
They were actually, it was kind of funny. Krishan's pretty awesome. I don't know if you guys have ever seen any of his artwork, but it's pretty awesome, pretty amazing. So in those classes, we do like Mythbusters, and like at the end, you can draw a picture that shows like what they did, or a picture of you in life. And he drew like Jacques Cousteau's submarine for this Gasol one, and I'm just always blown away by his artwork and stuff like that. But he had this amazing way of dealing with Jeremy. It was like, Jeremy, like, no man. You ever seen that little kid that's like telling his mom, Linda, listen,
Yeah.
listen,
Yeah.
Linda, listen. Like, you're trying to do that, but it was amazing. Listen. Yeah. Definitely fun. They didn't even give you this thing? Here's what you said. Cotton ball. You sure that it wasn't this paper clip and this thing?
No. It was literally a cotton ball and a paper clip, and there was like some bubble wrap, like a sheet of bubble wrap like this big. And it said like anxiety relief kit or something like that.
That's
And it was
amazing.
like, yeah, it was like,
They spent more time in the sign for it than they did, yeah. But they did you remember, like, right when the
yeah.
virus was coming out, they were like, here, you can give these to pass around to your students, and they can relieve their stress. Here's kids, yeah, that's all over the place. It's amazing. I bet the best one of these bits was made. I made it. Basically, they told me how to make it, and then I doubled everything, the cool stuff. Double glitter. It's like, a Subway sandwich with double meat. All right, let's get it. Spray these down. What's that? What do you got? All right, don't play it, Jesse.
Much more relaxed.
Yeah. I didn't keep it. I feel like you didn't tell us. I got on like when was it?
Maybe it's
Sunday,
gotten
and I was
many
like,
guys
what?
now.
I was like, well, I was Monday morning. I wanted to get all those signs that I could do today. And he was like, oh, you have a clue.
I got hand sanitizer up here too, if you guys need it. I got my pictures from me in 6th and 7th grade too. See if we can find them.
Wow.
Like that. Yeah, right? Now that's some 80s hair.
Oh my god.
That's Justin Bieber before Bieber.
Wonderful. Wow.
Yeah, it's funny. Me and Matt Stewart were the same. No, that's actually my best friend. That's the guy that went to jail and all that weird stuff.
Yep.
Yeah. Yeah, unfortunate. He's got his life together now.
That's
It
good.
took him about 20 years, but
You know what? Sometimes it's
it's that long, right?
probably gonna be my brother.
Really? Years. Which one?
My oldest brother. Oh yeah, the one that you had.
Really?
Yeah, he's a mess.
Is
He
this
has
the one?
long hair, no job, no career, no college degree. He's a mess.
He dropped out?
Yeah, he didn't finish. So
He living
he
at
one
home?
semester